All right, we have homework explained, detailed of section 6.6, adding mixed numbers, day 1. So first thing that they want you to see is, hey, first of all, let's convert 4 1/5 to a fraction. And in this case, we would convert it to an improper fraction. So we would do 5 times 4 plus 1. And so that's 5 times 4 is 20 plus 1 is 21/5. And whenever we add fractions, and especially these types of fractions, we're going to need to be able to see it as improper fractions. So number 1 is pretty easy. Number 2 is equally as easy. 8 times 2 is 16 plus 3 is 19/8. Number 3 is now we convert this to a mixed number, or an improper fraction, should we say. So 8 gets converted to 8 over 1. 1 over x is already a fraction. Now, much like in section 6.5, part 2, when we have unlike denominators, which we do in this case, we have to find an LCM, or a least common denominator. So we do the prime factorization of 1, which is 1, the prime factorization of x, which is x. What do they have in common? They don't have anything in common. What are the leftovers? Well, we have a 1 and an x as our leftovers. So my LCM is going to be 1 times x, or x. And that would be my common denominator. Now we need step 2. Step 2 is equivalent fractions. So equivalent, 8 over 1 equals how many over x? So we ask, what do we multiply 1 to get x? We multiply it by x. And so we have to multiply the numerator by x to keep it as an equivalency. 8 times x is 8x. So that is equivalent to that. And we notice that our original fraction here already has x as a denominator. So we know that we don't have to, that's already converted, it's already equivalent. Now we have like denominators, so we can combine their numerators over the one fraction. We can't factor the numerator, so we keep it as 8x plus 1 over x. Again, we have 3 over 1, 7 over a. Common denominator is going to be a. Equivalencies, 3 over 1 equals how many a's? We're going to multiply it by a to get 3a. And we see that it's already in a's, so we combine, we just rewrite that fraction as its original. We have like denominators now. Let's combine their numerators over one of them. We can't factor that numerator, so we leave it as 3a plus 7 over a. We again, 3a over 1 minus 2 over a. Common denominator is going to be a. Let's find an equivalency. 3a over 1 equals how many a's? We're going to multiply that by a. 3a times a is 3a squared. And 2 over a stays as that. Let's combine it. 3a squared minus 2 over a. Now we want to make sure that that numerator can't be factored. We should be testing this. All right, well, that has 2 terms and subtraction. So remember, we're looking at factor. Can it be factored? Can we factor it? And what we do is we look for a greatest common factor. No GCF of those. We look, is it difference of squares? Because that's 2 terms. No. 3 we don't have to check because binomial squares are 3 terms and this is only 2. A times C, no, because this is only 2 terms, and factor by grouping is 4 terms, so we don't. So this cannot be factored, so this is going to end up being my final answer. So we're always going to check for those 5 factorable things with our numerators and denominators. 5x over 1 minus 3 over x, my common denominator is going to be x. We have to convert it. 5x over 1 equals over x. We're going to multiply by x. We get 5x squared as its equivalent fraction. And now we're going to, again, put it all over 1. 5x squared minus 3 cannot be factored. So we just leave it like that. Can't wait until we can find a common or factor. All right, a over b minus 3 over 1. Common denominator is going to be b. A over b stays as a over b. So now I have 3 over 1 equals what over b? I'm going to multiply by b. Whoops. 3 times b is 3b. We have like denominators. Let's write everything in the numerator. And a minus 3b doesn't have a common factor, and it's not difference of squares. 2 over 1 minus c over d. Common denominator is d. We have to convert 2 over 1 to d's. We're going to multiply it by d. You get 2d. And c over d stays. So we get 2d minus c over d. That cannot be factored. 5 over 1 minus 4 over x plus 2. So let's go back to step 1, LCM. The prime factorization of 1 is 1. We're looking at our denominators. Prime factorization of x plus 2 is x plus 2. Remember, we can't separate things being added and subtracted. So when I find what they have in common, they don't have anything in common. And what are my leftovers? I have a 1 and an x plus 2. So my LCM is going to be 1 times x plus 2, which is just x plus 2. So that's going to be my common denominator, minus x plus 2. Now we got to find an equivalency. This is step 2. So we have 5 over 1 equals what over x plus 2? So this is where that familiarity of what you do when you have binomials. So you're still asking the question, 1 times what gives me x plus 2? Well, you would have to multiply it x plus 2. That's what would give you. And you have to multiply the numerator by x plus 2. So we get 5 times the quantity x plus 2. That already has x plus 2 as its denominator. So I just keep that numerator. And now we write it all over 1 denominator. And now we can simplify. So we have to distribute. Let's distribute that 5 into the parentheses. So we get 5x plus 10 minus 4 over x plus 2. We have like terms here. We have a constant and a constant. So that gives us 5x plus 6 over x plus 2. I look at the numerator. I can't factor that. There's no common factor. That's not factorable. It's not the difference of squares. So that would be my answer. We have 8 over 1 plus y over y minus 1. Common denominator is going to be y minus 1. So I have to find an equivalency. So what do I multiply 1 to get y minus 1? I multiply it by y minus 1. So that gives me 8 times y minus 1 as my equivalency. It's interesting on when I write it, when I write a y like that, and then when I change it to that. It's very unusual. And this is already in y minus 1, so I just put the y in the numerator. Let's put them over the same. I did it again. I'm going to write my y like that now. Y minus 1. Let's distribute that 8 into there. I get 8y minus 8 plus y over y minus 1. I have like terms. This time I have variables as like terms. 8y plus y gives me 9y minus 8 over y minus 1. I can't factor that numerator. There's no common factor. So that would be my answer. Gosh, I hope that we can do one where it simplifies after. Plus 6 over 1. Common denominator is going to be x plus 2, x plus 2. Let's convert the 6 over 1 to x plus 2's. We're going to multiply it by x plus 2, x plus 2, 6 times x plus 2. That stays because it already has x plus 2 as its denominator, and we're just converting this right fraction. Now let's write them all over the same. And showing that step, it took me 2 seconds to write that line. Just write it. Now we're going to distribute that 6 into it, and we get x plus 6x plus 12 over x plus 2. We have like terms. We have x and 6x, and that's going to be 7x plus 12 over x plus 2. Cannot be factored. We have a plus 3 over a minus 3 over 1. Common denominator is going to be a. That numerator stays. Let's convert 3 over 1 equals a's. We're going to multiply it times a, which gives us 3a. We get a plus 3 minus 3a all over a. That gives me, we've got like terms. We got a and negative 3a. We're always going to write our variables first. And we have first term negative, so I would definitely factor out a negative and get 2a minus 3 over a, which will be acceptable. But the better high school one is going to be 2a minus 3 over negative a. Well, Mr. Mack, doesn't that? Well, single terms can have negatives. It's multiple terms like this. You can't have negative as the first term. This is probably the best one because you have less parentheses. When you can move that negative down to it, you tend to do that. Ooh, all right, 4 over 1 plus 2n plus 1 over n plus 1. That common denominator is going to be n plus 1. And we know that that's going to stay the same, so we just have to convert 4 over 1 equals n plus 1. We're going to multiply it by n plus 1. So we get 4 times the quantity n plus 1. And 4 times the quantity n plus 1 plus 2n plus 1 over n plus 1. Let's distribute the 4 into the parentheses so we can simplify that numerator. 4n plus 4 plus 2n plus 1 over n plus 1. Like terms, now we have 2 sets of like terms. We have the variables and we have the constants. So that's going to give me 6n plus 5 over n plus 1. Cannot be factored. That would be my final answer. Come on, give me one that can be factored after we convert. Common denominator is going to be k minus 4. That's going to stay k minus 3. 2 over 1 equals what over k minus 4? We multiply it by k minus 4. So 2 times the quantity k minus 4. Write it as a single minus, oh, look at that. That's a crazy one. So because of that negative, we have to keep that together. That's probably where some people are going to make a mistake there because there's 2 terms that we have to distribute that negative. All right, so we have 2 distributions. This is good. So we got to distribute that 2 into that parentheses, and we have to distribute the negative into that parentheses. So we get 2 times k is 2k, 2 times 4 is -8, -1 times k is -k, -1 times 3 is +3, all over k minus 4. We have like terms, we have the k's that are like terms, and we have the constants that are like terms. 2k minus k is k, -8 plus 3 is -5 over k minus 4. Still didn't reduce it after the fact. All right. Whew, how many problems do we have here? Is this the last one? No. Is that it? Yeah, 16. So we got 2 more. Let's see if we can get one that will be simplified after we convert and combine. All right, common denominator is going to be x plus 1. That's going to be 6x times the quantity x plus 1. That's going to stay as x. Notice that I just sort of figured out what the numerator is going to be. Let's write them all over the same denominator. Now let's distribute. Let's simplify. You have 6x times x is 6x squared. 6x times 1 is 6x minus x all over x plus 1. Oh, we were so close there. We have like terms. You get 6x squared plus 5x over x plus 1. We can factor that numerator now. It has a common factor of an x. So that becomes 6x plus 5 over x plus 1. However, we can't cancel. We cannot cancel this x with this x. Yes, this one's multiplying, but this one's being added and subtracted. So we can't cancel it. But we're getting closer. We at least could factor after. Will this one provide us with an opportunity to factor after the fact? So y minus 5 is going to be my common denominators. That's going to be 4y times the quantity y minus 5. That's going to be y. 4y, sorry. That's going to be 4y times the quantity y minus 5 plus y all over y minus 5. That gives us 4y squared minus 20y plus y over y minus 5. Nope, not going to be able to do it again. 4y squared minus 19y over y minus 5. Factor out that y. You get 4y minus 19 over y minus 5. Boo-hoo. None of them simplified after we combined them. Bummer. Know that you will have to, those will simplify at some point. So lots of good work there. Make sure you come and check in with me if you have questions.